Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, graph the function f of x equals negative x to the fourth minus 7x cubed plus 5x squared plus 75x. All right, let's take a look at the steps for graphing a polynomial function. So we'll start with step number 1. Find the end behavior using the term with the highest degree. All right, so there are 4 cases for finding end behavior. Let's look at those cases here. So in ours, we'll bring down our function over on the right. Now we only care about the term that has the highest exponent of x. So we really only care about this term here. So I'll underline it in red. So we only care about the negative x to the fourth, because that's going to determine the end behavior. Now notice the exponent is even, so it's going to be one of these 2 cases here. Next we look at the coefficient. The coefficient is negative 1 in front of it. So that tells us it's this case here because the coefficient is negative and the highest exponent or degree is even. So we're going to have a down look here for the end behavior. So our end behavior is going to go down and down. All right, so I'm going to go ahead and group those together. We can get rid of our information here, and we'll save that in behavior for when we actually graph. Next is step 2. Find the y-intercept. So what's the rule for finding the y-intercept? Well, you plug in 0 for x and solve for y. So let's bring down our function here. So here is our function. We're going to plug in 0 wherever we see an x. And I'm plugging it in red just so you can see where we're plugging it in. So essentially all these terms are going to zero out. So literally all of them are going to zero out. So we're going to have 0 plus minus 0 plus 0 plus 0, which gives us 0. All right, so our y-intercept is going to be just 0 because every y-intercept has an x value of 0, 0, 0. Okay, so we'll write this down here. So this is our y-intercept. Okay, we'll save that information for later. So I'll put that right over here. So our y-intercept. Okay, we'll erase our work and then go to the next step. Step 3, find the real zeros, which are basically the x-intercepts, by factoring if possible. Now looking at this, we can actually factor a little bit. So if we can take out something. What do all of these terms have in common? Well, hopefully you said an x. So I'm going to take out actually a negative x. So if we take out a negative x, here's what's left over. So the signs are going to switch. So it's going to be x cubed plus 7x squared, and then minus 5x, and then minus 75. All right, and we actually now know one of our roots is 0. So I'm going to go ahead and circle that. So that tells us that one of our roots is x equals 0. So that's nice. We have one of our 4 roots. And we know we have 4 roots or zeros because the highest exponent of x is 4. All right, let's keep going here. So if you can't factor, which this will not be able to factor, you could try grouping, but it will not work. We're going to use the rational zero theorem along with synthetic division to find each of our other factors. So the rational zero theorem says that we're going to do all the factors of b over the factors of a. So b in this case is the 75 here, the constant, and a is the coefficient in front of the leading term. So here's our leading term, so that tells us that a equals 1. And then over here we have our constant, so b equals, and you always take the absolute value of it, so b equals 75. So we have a 75 here and a 1 here. So we write all our factors of 75, which there are a lot of them. I'll write them down here. So there's 1, 3, 5, 15, 25, and 75. And that's all over 1. All right, so if we simplify all the possible combinations, it's nice that there's a 1 on the bottom, because basically it just ends up being 1 over 1, which is 1, 3 over 1, 3, 5 over 1, 5, and so on. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 25, and 75. Okay, let's do synthetic division. I'll start by trying 1 and see if that works. So we'll try a 1, and then our factors are here. So we're going to put our coefficients, so 1, 7, negative 5, and negative 75. So 1, 7, negative 5, and negative 75. All right, and then we separate the remainder. We bring down our 1. So we're going to go through this kind of quickly. We multiply. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. Negative 5 plus 8 is 3. 3 times 1 is 3. Okay, this is definitely not 0. So since this is not 0, this is not 0. So 1 does not work. So let's try another number. Let's go ahead and try, I'm going to skip to 3. Let's try 3. Normally you probably try negative 1, but I've kind of done the work on the side, and that does not work. So let's try 3, see if that works. So plug in our same coefficients. Draw our line, remainder. Bring down the 1. 1 times 3 is 3. 7 plus 3 is 10. Then we do 10 times 3, which gives us 30. Then we have negative 5 plus 30, which is 25. 25 times 3, ooh, this is going to work out, 75. And we get 0 as our remainder, which is fantastic because that tells us that 3 is a 0 of the function. All right, so we have 2 zeros of the 4 so far. We have 0 and 3. We need to find the other 2, and that's why we have this here, our condensed quadratic, I call it. So we're going to write this with our x's. So this is a constant, x, and then x squared. All right, so let's go ahead and rewrite that over here. So we're going to have x squared plus 10x plus 25 equals 0. We factor. Factors of 25 that add up to 10. Well, that one's pretty easy. It's just 5 and 5, and everything's positive. So we set each of these equal to 0, and x will equal negative 5. And negative 5 again. So negative 5 is going to be a double root. All right, so I'll circle that in green. So we're going to have negative 5 as a double root. All right, so now let's rewrite our function. So our function is going to be f of x equals, remember we had the negative x out front, and we factored, and we got 3 as a root, and that only occurs once, so it'll be x minus 3 to the first power. And then we got minus 5 twice. So that'll be x plus 5 to the second power, because that's going to help us with the multiplicity. All right, so let's go ahead and erase our work here. We're going to erase all this work, and then we're going to now find whether at each x-intercept the graph crosses or touches. So our x-intercepts were 0, 3, and negative 5. All right, so based on our graph here, I'm going to group this together. Oops. And we'll bring it over here. Okay, so let's look at our multiplicity. So what is the exponent on this x? So that was 1, so I'll write that here. So our multiplicity was 1. So there's only one of the 0 zeros. And then 3 occurs also once, so that's 1 as well. Negative 5, though, occurs twice. So the multiplicity on negative 5 is 2. So what's the rule then for crossing or touching? So if the multiplicity is odd, then it crosses. So these two here, these are odd numbers, so it's going to cross at x equals 0 and at x equals 3. But since the multiplicity is even as it crosses negative 5, it's going to touch and come back. All right, so there's that information. I'm going to go ahead and erase our function. And next, we've done step 4. We've determined whether it crosses or touches at each x-intercept. Step 5 says if you need more points, you can plug in x values into a t-chart to round out the graph. So we'll skip step 5 for now. We'll just go ahead and graph. Okay, so now here's our graph here. And let's graph our y-intercept, so 0, 0. So that's right here on our graph. And then our x-intercepts are 0, 0, which we actually is the same point as the y-intercept. So We don't have to do that one again. Then we have 3 and -5. So here's 3. And then -5 is over on the left here, right here. Okay, I'll label that as -5. Okay, so now we have to make sure this works with our end behavior. So remember, it goes down and down. So we're going to come down here, and at -5, it's going to touch. Really important. At x equals -5. So it's not going to go through. That means it's going to come and touch this here. So I'll kind of graph what that would look like. So it's coming from the bottom. It's coming in here, and it's going like this here, and then it touches and comes back. Okay. Now at 0, it's going to cross. So that means we expect it to cross through here. So it's probably going to go down, up here, cross, and then at 3, it also crosses. So it's going to go like this and then like this, back down. And notice that agrees with our end behavior. So it's going to go like this here, and it's going to go down forever. So it agrees with our end behavior in that it goes down to the left, down to the right. So just to recap, we're coming from the bottom here. It touches at -5, crosses at 0, and crosses at 3, and allowing us to go down to the right forever, which agrees with our end behavior. So here's our graph of f of x. Now, if you wanted to find more points to get more specific, you could make a t-chart and plug in these x values here or these x values here, and that would probably make it a little bit more accurate, the graph. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.